Hello everyone, my name is Liam van Dreumel. Uh, I'm happy that you're all here listening to me. Unfortunately, I could not be there live, but I hope this video is still informative for you. Today I will be presenting a tool that I created. It's called Fair Trauma Reporting. This was made as part of a class that I followed called uh, Data Science in Practice, given by Mirjam van Rijssen. Now, before I show the tool, I will tell a bit more about myself. I'm currently a master's student at Leiden University, and I study IC in business and the public sector. In the study, I work on both business courses as well as IT courses, and that is how I came into the fair-related courses of Mirjam. So, in the next 10 minutes, I will tell you about the tool that we created. But first, it's important for me to show the names of the other team members that I had: Ruben Visser, Nikolai Pavlov, Camille van Schijk, and Arif Rahman. They all helped contribute to the tool, and it wouldn't be here without them. Unfortunately, they could not make it here today, but I'm happy to still show them and represent them as our team. So I will first explain the problem that we were presented with during the course, which then led to us creating a solution for it. Then I'll quickly go over the technical plan, how we came to our solution. I'll then talk about the regulatory compliance. I'll then show the implementation, how it actually works. Then some future improvements that can be made to the tool. And lastly, I will make some concluding statements. So first of all, the explanation of the problem. We were first presented by the following topic, which was a bit confusing to us. But it said that we had to create a fair-based ontology for traumatic events that happen in Africa. In the current situation, there's a biweekly report that is manually made, in which for each country there's about 2 sentences for each event that happens. This could be acts of violence, um, destruction of uh, medical resources, or famine, all kinds of bad things that happen here and that we want to pay attention to. That's why I make these reports. Now, it's very time consuming to do it all automatically, and it's hard to analyze the data that you have there. Unfortunately, we were not able to uh, create a tool for everything, so we really just focused on collecting the data, processing the data, and then make it ready for analysis. The reporting part we did not do, and that should be a different subject that someone else could tackle, or maybe it could be attached to what we already made. So we came with the following problem statement. The manual system for reporting trauma and diseases in conflict victims in Sudan, which is what we focused on, is inefficient, time-consuming, and prone to errors, hindering accurate and timely data collection, analyzing, and reporting. Now we skipped the reporting, but data collection and analyzing is still very much something we focused on. So what were the steps that we took? First of all, we looked at the data and how it is prepared. So we thought about how could we collect it and put it in our tool. Then we made some class definitions there. Because we weren't really sure what to do with the ontology, so we decided to make a classification system where we take the original data and then classify it by creating metadata. This will be more clear later on in the video. Then when we create the class, we mapped it to ontologies that we create ourselves. We then created an LLM prompt that can be used to input your data. Then we structured the data in which outputs it need to be. And lastly, we made an RDF conversion tool, which allowed it to be sent to a Lego graph. Now, of course, it also had to comply with the FAIR data guidelines. As you can see here, it is fair because, first of all, it's findable as we clearly structure our data through general conventions, and we create detailed metadata that can be used and is also ID'd. Secondly, it's accessible because it's all stored in centralized places that can be accessed by any user that has access to it. look at platforms like CDAR and Allegrograph. It's also interoperable because we use general formats anybody can use, and the tool itself has API integration. And lastly, it's reusable. The tool can be used many times. It can also reuse data as needed, and we have very comprehensive documentation in the tool. So now I'll quickly show you the architecture. We don't have to go through everything in detail. What's interesting to note is that we first started looking at SNOMED, trying to get the ontologies and vocabularies from there. We were not able to do that, so that's why we made our own. We also used the CEDAR platform to create templates in which you could put in the metadata. We also were not able to link CEDAR to our tool, so we kind of skipped that step and instead looked at the data that was provided to us. This could be local sources, so data gathered from people in Africa, or news sources, for example, URLs from web pages. This data gets together with an ontology list that we created, sent into our tool, which will then automatically classify your data and then create metadata from it in these three formats: XML, RDF, CSV, which can then be pushed to other platforms. So for regulatory compliance, luckily we did not have to do much. We had to see if places like CEDAR and Allegrograph were compliant, which they were. And because our tool is locally run on just one computer, or if you want on a local server, any sensitive data is safe and secure. So that is not something that we had to do too much work for. Now, what is the end product? We ultimately created a web application that allows users to input a data source, and then it gets classified and you receive metadata as an output. We use an AI LLM to read the data and then create metadata from it. It doesn't think of any metadata from the spot. Instead, we provide an ontology list with a number of ontologies and then related properties. And all the LLM does is look at the data, link it to the ontology it thinks it fits best, and then look at all the properties and says whether the property is present in the source. Then it gets marked as true, or if it's not relevant, then it's marked as false. This output gets then put into 4 formats, which you can download whichever you want. So now I'll show you a quick demo to make it all a bit more clear. So here we have the web environment. Once you launch the tool, you can open it in any web browser that you like, and then you start inputting your information. First, you for the event name, you can choose anything that you want. It doesn't really matter. It's more so for clarity for yourself. Then you fill in the date, the country, the region, and the most important is the situation part. This is the actual input data that you have. This could be just a plain text or a URL to, for example, a news page. Once you're done, you click submit, and here you get your output. This all is a bit unclear probably if you don't know what you're looking at, but luckily you can just click on the generate buttons and it creates the output for you. It will be downloaded to your PC and you are ready to use it. You can also directly send to Allegrograph, as we will show here. And once it gets sent, you can click on add another event and then start over again. But now we send it to Allegrograph. You can see here that currently before we had 0 statements. Now that we send it to there, we suddenly have 10 statements. So if we skip a bit further to the visualization part. You can now see the RDF that was created by the tool. So we had an original input, which was, as we go a bit back, a report of severe violence against women with some information about what happens. including rape and gang rape. And then if we look at the output, um, the data was linked to one ontology. It was classified as severe violence against women. And then you see in yellow we have the information that we provided, the uh, place and the date. And then the little gray ones are all the properties that the LLM marked as relevant. So these were marked true, and other properties like famine or something like that that was not relevant was marked false, so it's not shown here. So why is this useful? You have now classified your original data source and gave it properties. So now you could use this for further analysis. Maybe try to see if you can link it to other sources, see where there are similarities or where there are differences. And this could also be used for statistical analysis. So here again is the output. Uh, if you're familiar with XML, RDF, or CSV, you can kind of read and see how it's configured. It's all pretty standard conformity formats. So XML could be imported into CDAR, RDF can be imported into a lexicograph, and CSV was done for people who like to do some manual analysis through, for example, Excel. Here again is a visualization of the lexicograph, which we've already seen, so we'll just move on to future improvements. Currently the tool is only hosted locally. It would also be nice to maybe host it in an online environment. The only issue is then that we have to look more into the security because you're working with sensitive data, so you need to make sure that it doesn't get accessed by people that do not have uh, authorization. Secondly, there's not yet an automatic upload into CDAR, which would be very nice to add. We also don't have bulk uploads. Right now you have to do still one source at a time, which takes quite a bit of time. So it would be nice to just bulk upload them all into the tool. And lastly, we used our own created ontologies and properties. It would also be nice to be able to link them to dictionaries like SNOMED and get their very expensive list of ontologies to use that for the classification. These are all future improvements that hopefully one day can be added. So in conclusion, we had an original problem where you have a manual system that is very inefficient and time consuming to collect data, analyze and report it. Now we did not work on the reporting, however we did create a tool that streamlines data collection through a web application. Um, it classifies your data, creates metadata, and then allows you to analyze it further with tools like a lexicograph or CDAR. And we hope that this can give your organization impactful insights in the data that you collected, which can then hopefully be used to create good work in Africa or any other places that faces regular problematic events. So thank you all for listening to my video today. If you want to see more about the tool, you can scan the QR code that's on the screen here. And if you have any questions or suggestions, please contact me. So thank you all for listening, and until next time.